Good evening, everyone. My name is Vanshish. I'm a master's student at IIT Kanpur. I'm working at PML lab under Dr. Shantanu Mishra. Today I'm presenting theme 8, which is lab testing and validation for this conference. So first of all, we'll talk about the objectives. So the objectives that were assigned to us was the development of active distribution testbed and HIL validation. So one by one, we'll cover both of them. First of all, we'll start with the active distribution testbed. So the idea was to design a testbed which mirrors a part of a real distribution system, and also it can include various types of loads, lines, converters such as EV charger and solar converters. This test bed should have the capability which user can reconfigure it depending on various needs and various studies that they want to perform on the system. So we have developed this particular test bed. To do that, we have identified couple of components that would be used in this particular test bed. So on a typical distribution line, we will see a distribution transformer, three-phase cable, single-phase cable which will spread from feeder points, and various types of residential loads. So all these things has been integrated in this particular test bed. As you can see, this is one bay of a test bed. So there are various line modules, load modules, systems available for measurement, electronic loads, and various type of converters such as solar PV simulator, etc. So all these modules are plug and play type of instruments. So depending on the user requirement, they can change or vary various things regarding the studies that they want to perform. Now, the this is just a small part of a distribution system, right? So now, how would we connect? How would we test this with a larger system? So that is where the second part of the objective comes in. That is the PHIL simulation. So we had to develop a bidirectional power PHIL simulation validation system. So in a PHIL simulation, what happens is one part, which is generally the bigger part of the circuit, is simulated in a real-time simulator, and a smaller part of the circuit, which is the hardware under test, is connected with this particular simulator, and various studies can be performed and various performance parameters can be calculated. Now, as these two systems are, different system, one is the hardware system and another is the simulation platform. Obviously, these two cannot be connected directly. So, what needs to be done? A proper interface apparatus needs to be developed so that this particular connection can be done. So, to do that, we have so to do that, there are two things that would be required. One would be the communication module, and other would be a power amplifier. So briefly discussing both of these. So power, since this is an like real-time hardware system, and this is a simulation system which generally operates at very lower voltages, signal level voltages. So this power amplifier would cater to the power requirement of this particular load. It will amplify this particular voltage from low signal level to power level, and it also deliver the required load depending on this voltage value and the load value. And as these two systems are different system, one is a hardware system and another is a software system. For proper communication between these two systems, we need a proper interface module to do this communication, a synchronized communication between these two systems. So I'll now discuss one by one both of these interfaces. So first of all, we will start with interface between RTDS and power amplifier. So this interface contains two boards, two optical interface boards. One is connected on the RT side and other is connected on the power amplifier side. And both these boards are connected with fiber optic cables for a duplex channel communication. This is the board that has been developed and tested at IIT Kanpur. And also, it is the working of this board in which there is one input from RT side, then there is ADC DAC converter and the output at the power amplifier side. And for the power feedback from power amplifier side, there would be input ADC DAC conversion and then output at the RT side. This is the wave. This is typical 50 hertz signal that we can observe from this optical interface board from one side to the another side. So now we'll discuss about the performance of this interface. So there are two major things. One is the delay that is provided by this interface, which we can see in this slide. It comes out to be around 2.3 microsecond, which would serve our purpose in a well way. And other is the bandwidth. This particular interface has quite high bandwidth, and therefore it would be capable of transmitting any voltage transients occurring in the simulation to the real hardware system. Okay. So now coming to the next part of this interface, that is the power amplifier. So this, as you can see, this is the power amplifier that is developed and tested here at IIT Kanpur. So I'll cover its working. It is developed from a simple VSI topology. And as you can see, the control, it would give the VREF signal, and the MA of this particular inverter is controlled by this VREF, which is coming from the RT side. And this output current in the load is sensed and it is sent back to the RT simulator for PHIL simulation. Uh, so uh, uh, as we can see, this is the result of this particular power amplifier with this VREF, which is signal level voltage to this power level voltage, which is at the output. Also, we have put fifth harmonic in the reference signal, and we can see this power amplifier is able to amplify this particular voltage with the fifth harmonic in it as well. So for the sake of bidirectional PHL simulation, this power amplifier should have a bidirectional power flow capability. So that means if in case a source is connected at the load side and the power supplied by the source is more than the power consumed by the load, then this power amplifier should be able to sink the uh, excess power available at this particular node. So this was the typical power flow. Now, if inverter is connected, microinverter is connected at the output, uh, uh, slowly this load that is earlier that was being supplied by this power amplifier would be taken up by this microinverter, and this, as we can see in this particular uh, diagram in this particular result, that the power that is being supplied is basically negative, and this amplifier is acting as a sink. So that's how we will achieve this bidirectional PHL simulation by this bidirectional power amplifier. So now, as all these components have been tested individually, now the next part of this work would be to interface them and test them as a whole system. So that would be the future work that would be done on this particular project. So that was all from my side. I would like to thank you all for listening to me, and I would like if there are any questions on this particular presentation. Thank you so much.